And welcome to Tvaritam.AI. In this video, we are going to discuss data loading, dataset merging, and feature categorization. Now, data loading is a very simple step where you can directly import the dataset into your software. However, in a lot of real-world scenarios, data is stored across multiple datasets or database tables. Therefore, before building a machine learning model, we often need to combine these datasets into a single unified dataset. This process is known as merging the data. Merging refers to the process of combining data from multiple sources into a single dataset. So if you only have a single dataset, you can proceed directly with the model building. However, in most databases that the data is organized into separate tables, we need to merge. For example, in an e-commerce system, you might have a customer's data, a orders table, a products table. So these tables are connected through certain columns that allow us to relate the data between them. And when we want to analyze or build models using information from multiple tables, we need to merge them together using a common column. Now, to merge using a common column, we need to understand keys. A key is a feature or a combination of features that define the relationship between two datasets that are being merged. For example, in an e-commerce system, an order ID can be used to match order records across tables. Similarly, a customer ID may link the customer table with the order table. Keys are usually unique identifiers within a dataset. So your customer ID, order ID, business ID are the example of keys. In some cases, a single column may not uniquely identify a record. In such situations, we create a composite key, which is a combination of multiple columns. For example, if you have a company that operates multiple stores, in each store, the order ID is generated starting from 001. In that case, the order ID alone is not globally unique. To uniquely identify each order, we may need to combine the store ID and the order ID, and this combination is called a composite key. Now, after keys, we have to understand the joins. Joins help us understand how the datasets should be merged. And there are four common types of join: inner join, left join, right join, and full outer join. To understand them a little bit more, let us jump to this diagram. Now, inner join keeps only the records that exist in both datasets. For example, if we merge the customer's data and the order's data using an inner join, the resulting dataset that you can see will include only those customers who have placed an order. So C3 gamma is not in the resulting dataset, neither do we have the order number 3 that is placed by C4 who is not in the first table. Now, left join keeps all records from the left dataset and adds matching record from the right dataset. So left dataset is the first table that we have uploaded, right is the second table. And if there is no match in the right dataset, the corresponding column values will contain null values. For example, now you can see the customer table is on the left. All customer will appear in the result. C3 gamma also appears in the result. But customers who have not placed in the order again is appearing, but their order fields will contain null values. Right join is opposite. So right join keeps all records from the right dataset while matching records from the left datasets are added wherever possible. If there is no match from the left dataset, the left side field will remain empty or contain null values. So here for order 3, as there are no details for C4 in the customer table, this remains null. And a full outer join keeps all records from both datasets. If a record exists in one dataset but not in the other, the missing fields are filled with the null values. Now, after join, last thing that we need to understand before merging is relationship constraints. So when merging datasets, we have to understand that relationship constraints defines how many records from one table can relate to records in another table. In case we have one-to-one relationship, what is there? Each record in table A matches exactly to one record in table B. For example, company can have one CEO and one CEO can belong to only a single company. Now, second is one-to-many, where one record in table A or the first table can relate to multiple records in the second table. For example, one customer can place multiple orders, but each order belongs to only one customer. Third is many-to-one. So it is the reverse of one-to-many. Multiple records in the first table can relate to one record in the second table. For example, multiple employees may belong to a single department, but reverse is not possible. And many-to-many relationship is there when multiple records in the first table can relate to multiple records in the second table. For example, students and courses. A student can enroll in multiple courses. A course can have multiple students. Now moving forward with the implementation, we can just go to our load initial data. We click on load data and I will import the business profile. Now when I want to merge the data, I will choose merge additional data option. Now this time I will choose the monthly sales performance for every business that is stored here. Now we have to decide the keys. Business ID by default is the key here. It can check what is the common column. If we want to add another key pair, as we have a composite key, we can add another key pair option. We can click on this and add the required columns. Now select join type. This time I'll go with the inner join, and join constraint. If I go with 1-to-1 and I click on merge data, it will throw me an error. This error is there because the join constraint is invalid. First data set has business name, city, country. So a business appears only one with its details. But in the second table, we have the sales data where a business can appear multiple times. So logically, this is a one-to-many relationship. Now when I click on merge data, the data is merged. Now when we will go to feature categorization, we can see that we have this complete data that we have merged, and we can choose the input features and the output features. So here our total revenue would be the output that we will try to predict. We can check the data types. It automatically assigns a data type to the given column. But if you want to change the data type, you can choose string, integer, float or date time depending on the column and your domain. And you can also edit the category. You can change from continuous to categorical or vice versa. It automatically assigns based on the cardinality and the data type. But in case you want to change the category or the data type, you can just select and choose the desired data type and category, and you have to click on the update feature description. If you do not click on it and you switch the tab, this might not apply. So once you make the desired changes, click on update feature description and it will update. Here, this is additional feature that you get, that there is a warning that one feature has a cardinality 1 that might not provide us any information in the model. Right. So these kind of features that do not have any relevance to the model, like having a cardinality 1 or a random feature that you do not want to use for your machine learning prediction, you can just select the type as none. And when you select the type as none and you update, then this feature is automatically dropped. Thank you.